Hello everyone, let's solve problem 7, missing number in array. You will be given an array of n minus 1 size. All the elements are ranged from 1 to n. Find out the missing element. If you see within a given array within 1 to 5, element 4 is missing, so return 4. So the problem is almost equal to missing number from LeetCode. So let's move on. So one simplest solution will be we maintain a set, we copy all the elements into the hash set and later we will compare. So 2 we copy 2, 5, 1, 3. Then we iterate from 1 to n and we check in the hash set. So 1 is present, 2 is present, 3 is present. As 4 is not present, we return 4. So the time complexity is linear because we traversing from index 0 to n minus 1, and the space complexity also be linear because we copy all the elements into the set. So is it possible to improve the space complexity? Yes. The key is that all the elements are ranged from 1 to n. So it means we can map the element with index. So let's see how can we do that. So we can map element 1 with index 0, element 2 with index 1 because all the elements are ranged from 1 to n. So let's see how can we do that. So at index 0 we have element 2. Let's hash with index 1. So how do we hash? We simply update the sign of the element present in index 1. So earlier it was plus 5, now we update it to minus 5. Now let's move on to index 1. Now at index 1 you have a minus 5, but we updated the sign so that always take the absolute value. The absolute value will be plus 5. So you cannot find an index of nth element because the size of the array is n minus 1. So that to maintain the flag for nth element, you can have a boolean variable is n found equal true. As 5 is present, so we just say is n found is true. Now let's move on to index 2. At index 2 we have element 1. Let's hash with index 0. So we simply follow the principle as element k can be hashed with k minus 1 index. So at index 0 we just update the sign. Now let's move on to index 3. We have element 3. So we can hash with index 2, update the sign. So now we are done with hashing of all the elements with corresponding index. Now let's iterate through it. First we check is n found because we maintain the flag for it. As n is found, so 5 is present. Now let's move on to starting index. So at index 0 you have negative value, it means 1 is present. At index 1 also you have negative value, so that 2 is present. And at index 2 we have negative value, it means 3 is present. At index 3 we have positive value, it means 4 is not present, so we can return 4. So the time complexity here is linear. So first time we iterate through update the signs, second time we iterate through find out the missing number, and the space complexity is constant because we are not using any additional space, we are just using the existing indexes to maintain the hash. So we can also give a simplest solution with math. So let's apply math. So we know, right, we can figure out the sum of n natural elements using n of n plus 1 by 2. So the total sum will be 15. And find out the sum of the given element sum, which is equal to 11. So the missing element will be 15 minus 11, which is equal to 4. So the time complexity here is linear because we are trying to iterate the array to find out the sum of elements, and the space complexity is constant. So before moving on to solution, if you really like the explanation, please click on like button, share your thoughts through comments. So let's okay, so what we do, so I will write a solution for index hashing, so you can figure out a solution for just applying that math, right? So I'll just take a flag for is n found, which is equal to false initially. So what I do is I'll start from index 0 and index n minus 1, because the size of the array is n minus 1. So then index plus plus, and each time I'll get the element array of index. Then I'll see if element which is equal to n, so I'll just update the flag is n found is equal to, else so I just need to update uh, array of element minus 1 index with negative values simply. So I'll just take minus, just apply minus. So one of the key point is, whenever you are taking the value from the given index, you always take the absolute value. So because we are updating the sign, so that whenever you call math of absolute of the given element, it always gives the positive value. So that's it. So we are done with the updating of size, and later what we can do, so we'll just start from first. We'll check if is n found. If n is not found, then we can blindly return n. Otherwise, so we start from index 0 to n minus 1, and we'll see if any element, any index value which is greater than 0, it means the corresponding index plus 1 value is missing. So we'll just do a break here and just return the corresponding index plus 1 value. So or else you can return index plus 1 here. For simplicity's sake, I'm just returning minus 1 here. So this line number 16 will never execute. Just for avoid compile and time error, I just added it. So just run it. Let me declare int. That's it. Yeah, let me submit it. You can also find out the problem statement in the description. Please click on the problem statement, submit your solution, enjoy the day. So thanks for watching. Please do subscribe and share.